Moving on to section 6.3, 6.4. This is the most important section of all of chapter 6. We're solving systems of equations with the elimination method, also known as the linear combinations method. Let's first start with this class opener. It's a review of substitution. So step one on substitution is to pick an equation and get a letter by itself. So the top equation already has a letter by itself. It says y equals 2x. So what you do is substitute that value into the other equation, of course into y. That way your new bottom equation will read 6x minus y, but instead of y we put parentheses and you plug in that 2x equals 8. Once again, same exact equation. 6x minus y equals 8. 6x minus y, which is really 2x, equals 8. And now we solve the equation by either doing distributive property and combining like terms, but there is no distributive property, but there is combining like terms. This is 6x take away 2x. So that's really just 4x equals 8, which means if you divide by 4 on both sides, x equals 2. And that's one answer. Remember, a system of equations has a coordinate as an answer, an x value and a y value. So far you just have the x. We still need the y. So once you have an x value and you want the y value, just plug it into any equation you want. You could plug in the 2 right in here and say 6 times 2 is 12 minus y equals 8. Or you could plug in the 2 up here and say y equals 2 times 2. That's probably the easier option because 2 times 2 is 4, which means that y equals 4. So your y value is 4. And that's it. That's your answer for the system using substitution. Number 2, also ready for substitution because you have to pick an equation and get a letter by itself. And as you can see, the bottom equation already has a letter by itself. So let's plug in that variable expression that y equals into the other equation where the y is at. Now we're going to have a new equation over here on the side. It's going to read 3x minus 17 equals 2 times y. But the y value that we're plugging in is really negative 2x plus 2. So let's solve this equation. Let me zoom in so you can just focus in on this equation. Let's distribute first. 2 times negative 2x is negative 4x. 2 times 2 is positive 4. Bring down the equal sign. Bring down the rest. We have the 3x and the minus 17 equals negative 4x plus 4. And now we need to solve this equation, but of course we have x's on both sides of the equation. You don't want x's on both sides. You only want it on one side. So let's get rid of the negative 4x. So how do I do that? I add 4x. What you do to one side, you do to the other side. 3x plus 4x is 7x. Bring down the rest. Minus 17 equals 4. Of course, we need to get rid of that minus 17. So let's go plus 17, plus 17. We're going to have a new equation that says 7x equals 21. Final step would be to get rid of the multiplication of 7 in front of the x. So you do the opposite, which is dividing by 7. X equals 3. That is your answer. That is one answer, that is, because for the answer to the entire system, we know it's a coordinate. So far we have the x value, which is 3. We still need the y value. So all we have to do is plug in that 3 into any original equation that we want into the x to solve for y. Again, I think it'll be easier to plug it into this one right here. You could plug in the 3 up here, get 9 minus 17, and then divide by 2 and you get your answer. But I think this one's easier. Plug in a 3 right here and it'll read y equals negative 2 times 3. Let me show my work. Y equals negative 2 times the 3 that we're substituting in for x plus 2. So y equals negative 6 plus 2, which means y equals negative 4. And there's your answer to that next equation, or this system, I'm sorry. Let's move on to the last one we have to do. Now on this one, we have to pick an equation and get a letter by itself. As you could see, both equations do not have a letter by itself. So if you pick the x to get by itself down here, you'd have to subtract 5y, and then after that you'd have to get rid of the multiplication of 3 by dividing by 3. So obviously getting this x by itself is not the best option. Same thing for this y, you'd have to do multi-step. Same thing for this y, but this x is really just one step away from getting it by itself. So if I decided to pick this x to get it by itself, all I have to do is get rid of the plus 4y by doing the opposite, minus 4y. That'll cancel it out, which you do to one side, you do to the other side. So what we really have is x equals negative 4y minus 4. So we have a variable by itself. Step 2 is to take the variable expression and plug it into the other equation you have not used. So we're going to take that x value of negative 4y minus 4 and plug it into the x of the other equation, which is right there. So let me make more space here. Let me draw an arrow this way. Let me rewrite my equation. 3 times x, but of course instead of x, we're plugging in the negative 4y minus 4 plus 5y equals 2. Now we have an equation here, all one variable. We could actually solve this equation. Let me zoom in on this equation. All I have to do is distributive property and combining like terms. So we have the 3 times negative 4y, that's negative 12y. 3 times negative 4, that's negative 12. Bring down the plus 5y. Bring down the equal sign. Bring down the 2. There's our new equation. We've distributed. Now we could combine like terms. So let me combine the negative 12y with the plus 5y. You just do this in your head. You're not going to be showing any work here. So negative 12, you owe $12. You have $5. You're still going to owe 7 of those dollars. In this case, 7 of these y's. Bring down the minus 12. Bring down the equal sign, the 2. We're almost done. Let's continue working here. Let's get rid of that minus 12 by adding 12. Adding 12. We're going to have a negative 7y equals 14. And then I divide by negative 7 on both sides, because it's really a multiplication of negative 7 right there. So divide by negative 7 on both sides. You will get y equals negative 2. Ladies and gentlemen, that's one of the 2 answers that we need, because a system is a coordinate as a solution, has a coordinate as a solution. So our coordinate, our answer number 3, has a y value of negative 2. We still need the x value. So what we're going to do is plug in that y value into any equation. I think the top equation will be easier, but you could plug the negative 2 into the y on the bottom if you want. I want to go to the top. Negative 2 times 4. So let me rewrite this whole thing. X plus 4y, but of course we're substituting negative 2 in place of y, equals negative 4. So what I really have is x minus 8 equals negative 4. Add 8, you end up with x equals positive 4. So the x value is positive 4. And there's your answer to the system 4 comma negative 2. Of course, if I would have changed these standard form equations into slope-intercept form, and if I would have graphed them, they would intersect at the location of 4 on the x, negative 2 on the y. So today we're going to learn a new method called elimination method, or also known as the linear combinations method. So far, we've learned how to solve with substitution, right? And we've also learned how to graph each of the equations and find the point of intersection. That's also another way of solving, by graphing. So far we know by graphing and by substitution. And today we're going to learn about elimination method, also known as linear combinations method. So before jumping into reading the steps, looks like a lot of steps, it looks complicated, but the truth is it's pretty easy. Let's just go to this first system that we have up here. And so far, we could solve this. We could get this equation, rewrite it in y equals mx plus b form. So we could graph it. We could graph this one, find their point of intersection, and that would be our answer. Or we could pick a equation and get a letter by itself, and then we could substitute it into the other equation with the substitution method. But right here, we're going to try this new method called the linear combinations method. So what we're going to do is we're going to take this top line and this bottom line, and we're going to combine them, okay? Now, that's why they call it linear combinations method. You combine the top line with the bottom line, and you get a new equation. However, the whole purpose of combining the lines is to get a variable to eliminate. See, the problem with one equation is that it has an x and it also has a y, And you can't really get a numeric value as an answer, just one answer, right? Because there's two variables. But if you combine the lines and a variable eliminates, then you'll be able to have a simple equation. So you're probably thinking, what's he talking about, combining the lines? Well, it's kind of like if you put a big line down here and a big plus sign. So we will be combining the lines, but before combining the lines, we need to make sure that a variable actually cancels, okay? So the 5 plus 3, that doesn't cancel, that gives us 8, but the negative 6y with the positive 6y, that does become 0, and that does cancel. So you first need to make sure that a variable will eliminate, okay? So I already know that my negative 6y with the positive 6y will cancel, so I could start adding this 5x plus the 3x. Probably shouldn't have drawn that line, sorry. 5x plus 3x, and of course we get 8x. And we also know that the negative 6y and the positive 6y is 0y's. It'll cancel out. Bring down the equal sign, and then negative 32 plus 48, that's really positive 16. So ladies and gentlemen, we have a nice simple equation now. The equation is 8x equals 16. You want to rewrite it, make it look nicer? Okay, 8x equals 16. So now it's just a question of solving for x. Divide by 8, x equals 2. And remember, on a system, you have a coordinate, an x and a y value. The x is 2, you still need the y. So how do we find the y? Just like in substitution, how did we find the y before? You take the x that you already have and plug it into any equation you want, either the top or the bottom. I'm just going to go for the bottom. It doesn't really matter. I'm going to take this 2 and plug it in right there. So let me make some space and show my work. So the 2 is going to go in right into that x right there. And I'm going to have 3 times x, which is going to be 3 times 2. And of course we have the plus 6y equals 48. Let's solve this equation. 3 times 2, that's really 6, plus 6y equals 48. Let's subtract 6 on both sides. We will have 6y equals 42. Final step will be to get rid of that 6 that's being multiplied by the y by doing the opposite, dividing by 6. And you will have final answer, y equals 7. So your answer to the entire system is 2, 7. That was way easier than any other method. You simply combine the lines. It's called linear combinations method. You combine the lines to get a variable to cancel. It would be pointless to combine the lines if a variable doesn't cancel. What do I mean by that? See this one down here? It's not ready to combine the lines. It's not ready. I cannot go plus right here and just combine the lines. Why not? Because 2 plus 4 is 6x. 18y plus 18y, that's 36y's. And you still end up with an equation with 2 variables. The only reason why you should combine the lines is to get a variable to cancel. So sometimes you're going to have to modify one or both equations to get something to cancel. Let me erase this. And let's go back to the step-by-step instructions. Okay, step 1. Which, by the way, step 1, a lot of times it's done for you. It says make sure the equations are all lined up and organized. What do I mean by that? X is on top of X's, Y is on top of Y's, numbers on top of numbers, equal on top of equal, and so on and so on. So if we go up here to the one we already did, number 1, was it lined up? Yeah. X is on top of X's, Y is on top of Y's, equal on top of equal, number on top of number. Okay. Step 2. Multiply one or both equations so that either an X or Y value cancels out when you combine the lines. It says you may not have to do this step. We did not have to do that on step 1, on the first problem that we just did up there. So what I'm trying to get at here on step 2 is if it's not ready to cancel, if your variables don't cancel, you need to multiply one or both equations to get a variable to cancel. Okay? Once again, multiply one or both equations by a value so that either an X or Y value cancels when you combine them. So look at number 3. Number 3, we already said it's not ready to combine the lines. It's not ready. Why not? Because 2 plus 4 is 6. 2 plus 4 is 6. And 18 and 18 is 36y. So you have 6x plus 36y. The x or the y did not cancel. Once again, the whole purpose of combining the lines is to get a variable to cancel. So what we need to do in step 2, it says either multiply the one equation or both equations to get a variable to cancel. So you need to decide, what do you want to cancel out, x's or y's? And there's many roads to the same place. Some roads are quicker. So if you say x's, think about this. The only way that this 2x will cancel with this 4x is if this 2x was actually a negative 4x. So if you wanted to cancel out the x's, you would have to multiply this whole top equation. You'd have to multiply it all by negative 2. That way this will become a negative 4. That way when you combine it, it'll cancel out. But is that the quickest method? Is that the best method? No. Will it work? Yeah, that method would have worked. But there's a quicker method to eliminate y's. Y's are easier to eliminate. Why is that? Because this one's 18y. This one's also 18y. So imagine that. All I have to do is multiply the bottom equation by negative 1. That way, this will become a negative 18y. And when I combine it with the positive 18y, when I combine the lines, it will cancel out. So let me do that. Let me multiply the bottom one by negative 1. So I didn't do anything to the top equation, so I'm just going to rewrite it over here. It's 2x plus 18y equals negative 9. On the bottom equation, I multiplied everything by negative 1. It became negative 4x minus 18y equals positive 27. And ladies and gentlemen, now this new system, this new modified system is ready to combine and cancel. Okay, so let's combine the lines. What is 2x minus 4x? 2x minus 4x, that is negative 2x. And then, of course, the positive 18y and the negative 18y cancel out. Let me bring down the equal sign, and negative 9 plus 27 is positive 18. So this is our new simple equation. Now all I need to do is solve it. Divide by negative 2, divide by negative 2, and you will get x equals negative 9. That's one answer to your system. Remember, a system is a coordinate, an x and a y value. So far we have the negative 9 for x. And how do you find the y once you already have the x? Simply plug it into any equation, top or bottom from the original. Doesn't matter which one you pick. I want to go with the top one. Top one reads 2 times x. But of course, instead of x, I'm plugging in negative 9 because x really equals negative 9. And then I'm going to keep writing plus 18y equals negative 9. Once again, I just took that top equation, 2x plus 18y equals negative 9. I rewrote it, 2x plus 18y equals negative 9. And now I'm going to solve this equation. And 2 times negative 9, that's negative 18, plus 18y equals negative 9. And then I'm going to add 18 to both sides. So I'm going to get 18y equals 9. And for my final step, I'm going to divide by 18. A lot of people get confused right here because they have y equals 9 over 18. But you could reduce both top and bottom. You could reduce that fraction by 9. So that'll be 1/2. So y actually equals 1/2. So my y value is 1/2, or you could put 0.5. Ladies and gentlemen, that is your answer to the system. Let's say you're kind of confused about that because you got a fraction. Well, let's see what would happen if we plugged it in to double check. 1/2 for y, 1/2 times 18, that's just 9, okay? So we really have negative 9 right here. 2 times negative 9, that's negative 18, plus 9, that really does give you negative 9. Plug in a negative 9 right here, and that'll be negative 36. 4 times negative 9 is negative 36. Half of 18 is 9. So you have negative 36 plus 9. That really does give you negative 27. So we've double checked it. I am now absolutely comfortable that this is my final answer because I know it's right. I've double checked it. Check, check. Now number 2, that one's really easy because it's ready to combine and cancel, right? Step 1, are they lined up? Yeah, they're lined up. X is on top of X's, Y is on top of Y's, equals on top of equals, number on top of number. If I were to combine them, if I were to put the line and a plus sign, will something cancel? Yes, the X's will cancel. So you're ready to rock. Just go ahead and start working on it. What I want to do is pause this video right now and have you guys work on it. So, quickly now, the X's cancel. We have 3y equals negative 6. That's really 3 times y equals negative 6. So go ahead and divide by 3. Divide by 3. Y equals negative 2. That's one answer. You need the other answer, just plug it in. I want to take the negative 2 right here and plug it into the bottom equation. So my new equation right here on the bottom is going to be negative 7x plus negative 2 equals negative 16. So we need to solve this equation over here. I want to do that by adding 2 to both sides. So I'm going to have negative 7x equals negative 14. And of course, when I divide by negative 7, x will equal positive 2. A negative divided by a negative is a positive. So ladies and gentlemen, the answer to this system, hopefully you guys got this right, was 2 comma negative 2. And we already did number 3. Number 4. Step 1. Are they lined up? Yes, they are. X on top of x's, y on top of y's, equal on top of equal, number on top of number. Step 2. If you combine these lines, are they ready to cancel something out? So obviously 7 plus 1 is 8x, and that's 12y, so nothing cancels. So you need to modify one or both equations to get something to cancel. So there's many roads to the same place. Once again, you have to pick what's the quickest road. So what's easier, to cancel out the x's or cancel out the y's? I mean, maybe there is no easier one per se than this one, because you could cancel out the y's by making this become a negative, which it already is negative, negative 15, and the positive 15 would then cancel with the negative 15. Or you could make this regular x, change it to a negative 7x. That way it'll cancel with the positive 7x. So once again, your goal is to eliminate either the x's or the y's. And how are you going to do that? You're going to do that by modifying one or maybe both equations to get a variable to cancel. So what I want to do is cancel out the y's this time. I want to multiply the bottom equation, and I always put parentheses and show my work. I want to multiply the bottom equation by positive 5. So I want to put a 5 times. And my new equation will become 5x. It'll become negative 15y. And it'll become 5 times 20 is 100. Whoops. So my top equation, I'm not even going to modify it. It's going to stay the same. 7x plus 15y equals 32. And now they're ready to combine, because the 15 up here with the negative 15 will cancel out. So let's combine these lines. Let's put a giant plus sign right here. 7x plus 5x, that's 12x. And then the 15y and the negative 15y cancel out. The equal sign comes down. 32 plus 100 is 132. All we need to do now is solve this simple equation by dividing by 12. Dividing by 12. X equals 11. Once you have one answer, you simply plug it back into any equation you want in the original to find the other answer. Just plug it into the bottom one. Bottom equation says x minus 3y equals 20. So I'm just plugging in an 11 right there. There is nothing to distribute on the parentheses, so I could erase the parentheses and just leave it 11 minus 3y equals 20. So how am I going to get rid of that 11? I'm going to subtract 11. It's going to cancel. What I do to one side, I do to the other side. I will have negative 3y equals 9. 20 take away 11 is 9. My final step will be to get rid of that minus 3 by dividing by negative 3. So that means y equals negative 3. So my final answer for the system on number 4 is 11 comma negative 3. Whoops, why did I write that? Excuse me, sorry about that. Negative 3. That's our answer. So on none of these, we had to actually do step 1 where they were lined up, okay? But sometimes you will have systems. Let me just show you right here. Let's say you had a 2x minus 5y equals 8, and then maybe you had a 5y plus 4x equals 12. So you see right here, they're not lined up. You can't start canceling things out, okay? So what you will have to do is rewrite the bottom equation by switching the x's and the y's, okay? So step 1 is to line them up. On none of these examples we actually had to line up, but sometimes we will have to line them up. Also, sometimes you might have to modify both equations to get something to cancel. So this problem is actually, we're not going to have this challenging type problems today, maybe tomorrow. But if we think about combining the lines right here, these x's will not cancel out. You'll get 7x if you combine them. And if you combine these, you get negative 3y. So it will not cancel out the y's either. So it's not ready to combine the lines. You first have to make sure that either the x's or the y's cancel out. So since the x's don't cancel, the y's don't cancel, you either have to modify one equation or both to get something to cancel. So it doesn't matter which one you pick. If you decide to cancel out x's, you're going to have to look at the 3 and the 4 and modify this to something that's positive and modify this to something that's negative. That's the same exact value. So if I wanted to cancel out x's with 3 and 4, this would have to be like 12 and this would have to be negative 12. Or if I wanted to cancel out y's with a 2 and a 5, I'd have to change this to a positive 10 and change this to a negative 10. So this is actually modifying both equations. So let me show you what I'm talking about. Let's go with the y's. I want to cancel out the y's. So I know that I'm going to have to multiply the entire equation by positive 5. Why is that? So I could end up with a positive 10y right here. And on the bottom equation, I'm going to have to multiply that whole thing by positive 2. Why positive 2? Because 2 times negative 5 will give me the negative 10y. That'll cancel out with the positive 10y. So right here's an example of me modifying both equations to get a variable to cancel. So the top equation, that's going to become 15x. It's going to become plus 10y. It's going to be equals negative 26 times 5 is negative 130. And then the bottom equation, 2 times 4x, that's 8x. 2 times negative 5y, that's negative 10y. And then 2 times negative 4, that's equal to negative 8. And now we're ready to combine the lines. Why is that? Because the 10y and the negative 10y cancel out. So 15 plus 8, that's 23x's. Bring down the equal sign, and this becomes negative 138. If you owe $130 and you owe another $8, you're going to owe $138. Final step will be to divide by 23. Divide by 23 cancels. X equals negative 6. That's one answer. Now remember, it's an actual coordinate that you need, an x value and a y value. We so far found the negative 6 being the x. Let's find the other one by plugging in the negative 6 for x. I want to go with the top equation this time. It says 3 times x, but of course we said x is negative 6, plus 2y, right? If I keep reading, plus 2y equals negative 26. Let me write that down. Plus 2y equals negative 26. So I really have 3 times negative 6, that's negative 18, plus 2y equals negative 26. And then we're going to add 18. Add 18. I will have a new equation that says 2y equals negative 8. And for the final step, you divide by 2, which means that y equals negative 4. So negative 4 for y. So there's your answer to that system. X is negative 6, y is negative 4. If you wanted to double check it, plug in your x into the x, plug in your y into the y, and see if it actually gives you negative 26. Plug in your negative 6 for x, plug in your negative 4 for y, and see if it actually gives you negative 4, which it does. I'm done. Good luck.